This video will show you how to solve simple problems with Atwood machines where you're looking for the tension in the cords. This example here will show you specifically with a massless cord and a massless pulley. Alright, so we've worked through this problem before where we just found the acceleration of the system. And to give a brief recap, essentially what we want to do is we want to think about the fact that this has 50 newtons, using 10 as G, pulling down this way, and this has 30 newtons pulling down this way. This one also here has T2 pulling up, and this one here has T1 pulling up. Now, if we think about just the system, we're thinking about this external system here. We're thinking about what forces are pulling on the system. We have this 50 Newton force, and we have this 30 Newton force. So the net force, F net on the system, is equal to 50 minus 30, or 20 newtons. The result is that with an F net of 20 newtons, that will give us the mass of the system times the acceleration of the system, and the mass of the system, remember, is 8 kilograms here. So 8 times our acceleration is equal to 20, so the acceleration is equal to 2.5 meters per second squared. Now, knowing the acceleration of the system, we know that this one over here is going to have an acceleration down, and this one here will have an acceleration up. So that will help us as we determine our directions for net force on each object. So now we can think about the 5 kilogram object. The net force expression for this is going to be F net on the 5 equals mass of the 5 times acceleration of the 5. So 50 minus T1, right, because the 50 is going to overcome T1 because our acceleration is down. 50 minus T1 will equal 5 times our acceleration of 2.5. So 50 minus T1 equals 12.5, and thus T1 equals 37.5 newtons. So this 5 kilogram object has 50 newtons pulling down, 37.5 newtons pulling up. Now if we go over here, F net of the 3 will equal mass of the 3 times acceleration of the 3. So this will be T2 minus 30, right? Because T2 is going to win because acceleration's up, will equal 3 times the acceleration of 2.5. So T2 minus 30 equals 7.5. So T2 equals 37.5 newtons. Now, you should take note that these two forces, T1 and T2, are equal. That is a result that will always hold true when we have a massless pulley and massless ropes. So for massless pulley and massless ropes, the tension in the cord is constant.